Good afternoon, folks. This is Mike, coming back at you with another video on college algebra. In this video, we are going to continue to look at conic sections, and specifically, we are going to look at ellipses. Just first off, what is the definition of an ellipse? An ellipse is the set of all ordered pairs or set of all points, x comma y, in a plane such that the sum of the distances between each point x comma y and two fixed points called the foci, and foci is simply the plural of the word focus. So we don't say focuses, we say foci. The sum of the distances between x comma y and one focus and x comma y and the other focus, that sum is a constant. So in our previous video, we looked at circles. How is a circle a conic section? Well, if you take a look here, the general conic section, typically we think of the cone as one of these two things. We think of there's a pointy end and then it goes up and out in a circular kind of fashion from there. But a true conic section is actually two things. The ends touch at one point, and then they go up and down and outward in a circular fashion like this. A circle is what we get as a result of taking a plane, a horizontal plane, think of like a piece of paper, and if I were to take that plane or that piece of paper, if I were to chop it flat through this cone, where the plane or where the paper and where the cone would meet, that would be a circle. That shape that you get is a circle. To get an ellipse, you're going to take that piece of paper and you're going to chop it through the cone, but at an angle. You are going to chop at it not quite with the same slope as this edge here, something a little bit more or something a little bit less of an angle, typically something a little bit less. But here we can see circle, flat through the conic section, flat through the cone. To get an ellipse, you're going to go at a little bit of an angle through the cone. So we have some important features of ellipses that we want to get out of the way. The foci, there is a line that you can picture that goes through the foci, and the line through the foci intersects the ellipse at 2 points. The points where the line through the foci intersects the actual ellipse, those are called the vertices. And the line segment with endpoints at each of your vertices is called the major axis. The center of an ellipse is simply the midpoint of the major axis. It's the midpoint of your two vertices. And then the line segment that's perpendicular to the major axis through the center is called the minor axis. And these are the two general types of ellipses we can have. The one at the left here, this is an ellipse where the major axis is horizontal. In this specific case, it's on the x-axis, but in general, the major axis is horizontal. Each of our vertices, right here, that line segment between those two vertices, that is your major axis. Halfway between the vertices is your center, and then the perpendicular line segment that goes through the center is called the minor axis. At the right here, so this was at the left, at the right here, is where we have an ellipse where the major axis is vertical. Vertices on both ends of the line segment that is our major axis. Halfway between those vertices is the center, and then the other axis there is our minor axis. Now, we said that an ellipse is a set of all points such that the sum of the distances between x comma y and two fixed points is a constant. What is that constant? Well, the sum of the distances between x comma y on the ellipse and the foci is 2a. Where does this a thing come from? I'll mention where the a comes from in the statement of the formula. I'm not going to go into sort of the proof of why that is what that is. That's sort of a bit beyond the scope of this course. It's not something you really need to know, but where does this a thing come from? The standard form for the equation of an ellipse that is centered at the point h comma k takes on the following form. X minus h, quantity squared over a squared, plus y minus k, quantity squared over b squared, is equal to 1. Now, that's not the only one. There is one that is very, very, very similar, and there is only a slight difference, but that slight difference does have an impact on the ellipse that we have and what this thing looks like. So we have a nice little chart that sort of breaks down what are all the key pieces and what are they saying. So first off, the general equation here. This is the one that we just saw. X minus h squared over a squared plus y minus k squared over b squared is equal to 1. The other way you could see it is x minus h squared over b squared plus y minus k squared over a squared is equal to 1. Now, what really makes these different from each other? It's the fact that a is greater than b, and both things are positive. So if a is greater than b and both things are positive, then that means that a squared is going to be greater than b squared. Making that note there. So based on which number is larger and where that larger thing is, that's going to dictate whether we have a horizontal major axis or a vertical major axis. So if the a squared is larger, well, it is always going to be a squared is always the larger of the two numbers on the bottom. B squared is always going to be the smaller. But if the larger number on the bottom is underneath the x's, then you have a horizontal major axis. If your larger number of a squared is underneath the y's, then you have a major axis that's vertical. But no matter whether you have a horizontal or a vertical major axis, the center point of your ellipse is going to be h comma k. There are some impacts, some slight impacts about the foci and the endpoints or the vertices, and then the endpoints of your major axis, of your minor axis as well. My apologies. The foci. If you have a horizontal major axis, the foci are going to occur at two ordered pairs. It's h plus or minus the square root of a squared minus b squared, comma k. If your major axis is vertical, your foci will be at h comma k plus or minus the square root of a squared minus b squared. Now, in the textbook, you're going to see the letter C. And there's a relationship between A, B, and C. C squared is equal to a squared minus b squared. So really what we have here in each of these cases, each of these things is really just the letter C. But since pieces of our equations were given in terms of A and B, I figured let's leave these things in terms of A and B as well. But I want to show you that C value there because it does show up inside of your text. The endpoints, or the vertices of your major axis, are going to be h plus or minus a, comma k. That's if your major axis is horizontal. If it's vertical, it's going to be h, comma, k plus or minus a. The endpoints of your minor axis, if your major axis is horizontal, it's going to be h, comma, k plus or minus b. And if it's vertical, it's going to be h plus or minus b, comma, k. Just as a quick note, the length of the major axis is always 2a. The length of the minor axis is always 2b. That's just a little fun side fact. Whoop-de-doo. Now we get into the actual types of problems that I want you to be able to know how to solve. So first thing you should be able to do is if you're given the equation of an ellipse, you should be able to identify the key features of the ellipse. That is to say, you should be able to identify the foci, the center, the vertices, all those kinds of things. So here, given x minus 2 squared over 9 plus y plus 4 squared over 49 is equal to 1, state the center, the foci, and the vertices of the ellipse. So, looking at this equation right here, and when you attack any problem like this, first thing you want to do is you want to identify where the larger number is happening on the bottom. We have 9 here, we have 49 here. Last time I checked, 49 was greater than 9. So the larger value is happening underneath the y's, and we said going back up here, when the larger number happens underneath the y's, then that means we're going to have a vertical major axis. So I'm just going to make a quick note of that here as I go through this sample problem. Vertical major axis. So we need the center, the vertices, and the foci. So we're looking at our general equation form up here, x minus h squared, y minus k squared. When that happens, the center point is h comma k. So if I go down here, I see I have x, as I throw my pen, in sheer anger. I have x minus 2 squared plus y plus 4 squared. So making those comparisons and seeing what's my h and what's my k, x minus h, x minus 2, my h value is going to be 2. Y minus k, y plus 4. You may think that the k value is positive 4, but it's not. It's actually going to be negative 4. So the center point is 2 comma negative 4. All right. So we can move on to our vertices next. For an ellipse who has a vertical major axis, the vertices occur at h comma k plus or minus a. So we need to figure out what that a value is. Well, keep in mind, we said that the larger number happened on the bottom of the fraction that had our y's. So this is our a squared, if you compare it to the general form. 49 is a squared. So that means that a is going to be 7. And because we're going to need it for our foci, this number 9 here, that's our b squared. So if b squared is equal to 9, then b is equal to 3, just taking the square root. Again, a and b are both positive, so we're always using the positive square roots here. But as we just said, the vertices for vertical major axis occur at h, comma, k plus or minus a. So the vertices, h remains the same, of 2. It's then k plus or minus 7. K value of -4 plus or minus my a value. Now, this will give us 2 separate ordered pairs. We just need to figure out what those 2 ordered pairs are. So I can have 2 comma -4 plus 7, which is 3. And we can have 2 comma -4 minus 7, which is -11. So those are our vertices for this particular ellipse. The foci. Foci for an ellipse with a vertical major axis, given by this formula right here. H, comma, k plus or minus the square root of a squared minus b squared. So going down here and doing our calculation, 2 comma -4 plus or minus square root of a squared, 49, minus b squared, 9. And in many cases, as we see, or as we will see here, you don't always come up with something very nice in your square root. Maybe it can be simplified at least a little bit. Maybe it can't. But what you get here is 2 comma -4 plus or minus the square root of 40. And this is 2 comma -4 plus the square root of 40 is equal to the square root of 4 times the square root of 10. And the square root of 4 is 2. So we have -4 plus 2 times the square root of 10. And then we can also have 2 comma -4 minus 2 times the square root of 10. Yes, it's not the prettiest things for the foci, but nonetheless, we still just have to work with what we are handed. So this is our first sample problem here in figuring out the key features of an ellipse, just given the equation. Well, not all ellipse equations will be given to us in that nice form. Here is an example of where we may not see something in that very nice form. Given 64x squared plus 25y squared equals 1600, we're again going to state the center, the foci, and the vertices of the given ellipse. This is like a slightly incognito standard form for the equation of an ellipse. There's one little operation that we have to do in order to turn it into that standard form, that we know how to work with. What we have to do in this one particular case is we simply have to divide both sides by the number we have on our right-hand side. I have to divide both sides by that 1600. And when I do that, that is going to get me x squared over 25 plus y squared over 64 is equal to 1. Right there. Just y squared over, x squared over 25 plus y squared over 64 is equal to a positive 1. So now we have something in a standard form. Now we can work with this thing. So we need the center, the foci, and the vertices. Well, again, first of all, let's just identify whether we have a vertical or horizontal major axis. Again, we're looking for where the larger number is happening. Is it happening underneath the y's, or is it happening underneath the x's? In this case, it is once again happening underneath the y's, so we know we're going to have a vertical major axis. Easiest thing to first find is our center. Looking at the tops of these fractions here, we see that we just have x squared and we just have y squared. Comparing that to that nice sort of general form of x minus something squared plus y minus something else squared. What are these somethings? What are my h and my k value going to be? Well, we can think of x as just x minus 0, and we can think of y as just y minus 0. These are the same things here. It's just a slightly different way in which we write them. So using this version, it might be a bit easier to see that our center here is going to be the origin. In this case, it's going to be the point 0, 0. We saw from our previous problem that for the vertices and for the foci, we are going to have to come up with our a and our b values. Remember, the larger number that's on the bottom, that's your a squared. So this right here is a squared, which means that your other number is b squared. And thus, it doesn't take too long to figure out that your a value is going to be 8, and your b value is going to be 5. The vertices, once again, those happened at h, comma, k plus or minus a. So that is 0, comma, 0 plus or minus 8. And that gives us 0, comma, minus 8 and 0, comma, positive 8. The other thing we need is our foci. And we know that, looking back at our formulas of vertical major axis, the foci is h, comma, k plus or minus square root of a squared minus b squared. So it's going to be 0, comma, 0 plus or minus the square root of a squared by 64 minus b squared by 25. And 64 minus 25 is 39. So this gives us our 2 foci, 0, comma, minus the square root of 39, and 0 comma plus the square root of 39. And again, we didn't get the prettiest thing, but having that calculation for the foci in there, where we're taking the square root of the difference of two things, that doesn't always leave us the nicest thing that is left over. But hey, to be honest, there's not a whole lot we can do. So these were our two sample problems here in being able to take a given equation for an ellipse and being able to state the key features of it, like centers, vertices, and foci. We're going to stop here for now. In the next video, we are going to continue working with ellipses, and we are going to see some other types of problems that you should be able to solve pertaining to ellipses. So if you guys have any questions or comments, please be sure to reach out to me, emails, texts, phone calls, star signals up in the sky, emergency flares, whatever you have to do. Until the next video, take it easy, guys.